Hi, my name is Jay Lewis. My mission is to make better simulations so we can make better decisions. Today, I will talk about how to pick what software to use to do a simulation and how to get started from almost nothing. So we have this model. We want to bring Uh, we want to compare two scenarios. The first one is a default plan to deorbit the ISS by crashing it into the most remote location in the ocean called Nemo. And um, and once that is done, there's also very large debris that would also need to be brought to the same location. Um, so So the alternative, once we have a tug that can bring debris to places, then why not bring it to a salvage station instead? And this salvage station can start with the ISS itself. So that can be salvaged. All these derelicts can be salvaged. The question is, my intuition is that the energy to do this is about the same, so we might as well salvage it. But um, it's possible I'm just wrong and I don't understand it. Um, we could use Excel for this. Uh, the problem with Excel is it quickly gets overwhelmed and you end up trying to do so many formulas and copying and pasting many subsections that at some point you should have just gone ahead and done some programming. Um, so once you've decided it's time to uh, make a real program that you can reuse for optimizing later, what tool do you use? And there, I would say, three main choices. MATLAB uh, has been used by the space industry and many others for this sort of problem. Python is a free version of MATLAB that's more powerful in many ways and has more examples. It's also user friendly and free, so that has many advantages. The main disadvantage with Python is I find the graphic results to be difficult to make and very ugly. The best, most attractive simulations I've seen were done in Unity, and the problem with Unity is it has fewer examples and is much harder to work with. So, so that's the first decision: is what software do we use? Um, the next question is how do we get started? The hardest thing is a blank sheet of paper. We don't have to do that. There are two repositories that have a um, good selection, and that that's a good place to start. So let's do that. So this is a GitHub. It's a wonderful place to find lots of work. Very smart people have provided um, the what's interesting about this. So the hashtag, this is a topic, low Earth orbit, and there are seven things here, and you can see what they are. So the first one's a Python, the second one's a Python. This third one is MATLAB, and they also provided a screenshot of the output. So this is very interesting. And there's another MATLAB, um, one that has no code in it yet. this is a placeholder of some sort. Um, they, who knows what they'll put in there? MATLAB again, Python again. So for this one topic, it's basically half and half MATLAB and Python. Um, as I was saying earlier, I lean towards Python. Um, the MATLAB code actually, if you have MATLAB code, you can look at how they solve the same problem and then do that in Python as well. So it's still the code is very readable. They have a certain way to do things that is different, but the formulas in there are really what will be most useful in Python. Um, Another place is Stock Exchange, and I did some Googling to find this one. I really like it. Um, this particular example program, um, these are the basics. If we have circles for the Earth and circles for our objects like the space station and the derelicts that we want to deorbit, we could probably zoom into a quadrant that is interesting to make it easier to see what is going on if it gets too busy. We can use colors. There's probably other ways we can show this. We can have it output the numbers that we want. Not that you couldn't do that in MATLAB or Unity. Um, so this is a good one. I also found at Stack Exchange a Unity discussion. This is inside this isn't the output of Unity. This is the model being set up. Um, there, it's very cinematic. You think about lighting a lot and camera angles. This is probably why the Unity results are so attractive. Um, it's meant for that. But as a simulation tool, um, this person said he was bogged down for a month trying to solve this himself, and I really rather get the answers faster than that. So I don't want to make a big complicated model and then realize that I'm not even working on the right problem. So the sooner I can get some results, the better. And we can always, once we have a working model in Python, we can always um, do reuse some portion of that in Unity to make a better, more attractive version if we need to. So this is the program that will be the basis of this simulation. Uh, the next step is to copy this into your environment. I use Anaconda, and I was going to record that this morning and discovered that um, my setup had issues, and then when I started to fix those, I found out I didn't have enough hard drive space. So um, for now, I'm just going to outline the next steps. So first, copy this um, into your workspace and rename it. So there's an original. I always add a link and a comment of where I found it. I want this person to get full credit. One interesting thing is that exploring this database that they mention, um, it that's actually probably going to be very useful for identifying where the debris is. And so this is actually even it's not only the best choice for what I want to do, it's also got even more than what I was looking for. So I'm very happy about that. Um, Once there, it needs to be ran exactly as it is to debug that. We're mostly going to be debugging our workspace to make sure we have all the right libraries. and that it will make the same results that they had. Um, and then once this looks exactly the same on our computer, then the next step is to plug in. We want other lines for the debris. We want the ISS. This is pulling from a database. That might be the easiest way to go, to just pull from the same database, or it might be better to look at pulling from our own spreadsheet or just hard code in the numbers we want. So, so this is good enough for now.